the world has begun to recognize the need to add alternative and renewable energy sources to the existing system. And wind energy is one of the key contributors to the changing energy landscape. Keeping global warming under 1.5 degrees Celsius will require massive additions to the renewable energy sector. And if this is tackled correctly, then wind power and other renewables could supply 70 to 85% of the world's electricity by 2050.
Well, wind energy is one of the fastest growing industries in the world and has been for the last kind of 20 years. And really a remarkable success story, from a business or a kind of industrial point of view. And the reason it's grown is because the world needs power and we need clean power. There's a few technologies that can produce the amount of power we need, and wind power is one of the leading ones and was one of the ones that grew fastest, along with solar PV as well. It started off as something fairly niche within power systems and was seen as something quite expensive, and now with the scale it's taken on, that's allowed it to become increasingly competitive, to the point that it's now more competitive than fossil fuels.
In 2005, the Global Wind Energy Council was established to provide a credible and representative forum for the entire wind energy sector at an international level. Their mission is to ensure that wind power is established as one of the world's leading energy sources.
Wind energy is still a relatively small part of the overall pie in terms of energy production, but it's the fastest growing, and we're the biggest source of new energy in many markets. Wind has also become a major source of employment directly and indirectly, and a source of economic regeneration in places that weren't doing very well. So offshore wind, for instance, has become really the growing industry in many coastal regions around the UK. And so you're seeing places that were really quite economically deprived now being reactivated by offshore wind. And these are new jobs, these are new skilled jobs. So one of the things that we're involved in also is capacity building and training, and really getting people ready for this new energy industry. What we know as the modern wind turbine kind of has its genesis in the 1970s, when you have the three blades and the cell. I mean, basically the basic configuration is kind of put into place in the 1970s, and I guess the most noticeable thing about the evolution of technology is things just get bigger. So we start off with these very small turbines producing kind of a couple of hundred kilowatts, and now we're up to turbines that are in the megawatt size, and then the turbines have gone from something that's the height of a small house to something that's now the size of the Eiffel Tower, literally. The main thing has been about capturing increasing amounts of energy by the turbines getting bigger, but then there's also a story behind that of more efficiency, better materials, lighter, stronger materials, and then increasingly over the last 10 years the impact of information technology and artificial intelligence, so the turbines are getting intelligent, and by that I mean they can tilt, they can move around to capture better wind. The turbines in the wind farm can talk to each other, so they can anticipate the wind coming from one side of the wind farm to the other side of the wind farm.
Thanks to the growing demand and the lower costs of wind energy, many companies are emerging in that sector that are able to take wind energy to places that previously may have seemed unreachable.
We see that the turbines becomes more and more efficient, so that the levelized cost of energy is going down. That means that wind energy becomes more and more competitive to conventional power plants. So it is very clear that without wind power, we will not reach our targets of 100% renewable energy. PNE is one of the most experienced wind farm developer onshore and offshore. We are working in 12 countries and 3 continents. In the course of our new strategy, we see ourselves as clean energy solution providers. We are striving for 100% renewable energy. We say also clean energy in future, and decentralized energy. As we are aiming to expand in international markets, it's absolutely necessary to have an overview and an idea about the market. In this respect, GWEC helps us to understand markets and with their researches and their outlooks to give us a feeling where we should be in the future.
Building wind farms on land, what we call onshore wind farms, have traditionally been the primary form of capturing the potential of wind. But in the last few years, offshore wind has emerged as an increasingly important technology to power the energy transition.
Where you have constraints over space and high population densities, it's far easier to put an offshore wind farm in the sea. You're not going to get objections. Most people can't even see them because they're off beyond the horizon. So you're going to have places like Northern Europe, Japan, where it's actually quite hard to do things onshore because of space constraints, and there's no space constraint in the oceans, right? So you can literally produce as much power as you want, and the technical potential of offshore wind is enough to supply power to the entire world many, many, many times over. And then you can do much bigger projects with bigger turbines, and you can add on chunks of zero carbon power pretty quickly in a kind of big industrial scale. And that's what's happening, and that's why offshore wind is gaining such momentum.
The world's largest offshore wind power developer is a company called Ørsted.
We need offshore wind because it's really the only technology currently available to us, which is going to allow decarbonisation of the world's energy systems at the speed, at the scale, and at the cost which is necessary in order to ensure that we can all meet the Paris climate change agreements. We have developed offshore wind farms from the very first offshore wind farm off the coast of Denmark to now building 1.2 gigawatts in the UK, to the first commercial scale offshore wind farms in Taiwan and in the US. Over the past few years, offshore wind has taken its first steps outside the EU, where it really started, towards commercial scale offshore wind farms in both the United States and also in the Asia-Pacific region. We've seen states up and down the east coast of the United States and also Asia-Pacific countries defining really ambitious and exciting targets for offshore wind deployment. The offshore wind sector really benefits from having an organisation like GWEC, which is able to gather best practices from the more established offshore wind markets and transfer them to the newer offshore wind markets, so that the world is able to transition more quickly to a world that runs entirely on green energy.
The growth of the wind industry is possible thanks to new technologies being rapidly developed that make it possible for wind power to take on a bigger role in the global energy system. And this growth has also been driven by traditionally fossil-based organizations now turning their attention towards renewables.
Shell likes new energies because we see that's where the world is transitioning to. We are a total energy company, so that also includes new energies such as solar and wind. We see offshore wind has a big promise to transition the world's energy demand. We see ourselves as a developer. There is a bright future for offshore wind. There are very large growth projections, which is wonderful, but it can only be accomplished sincerely if you have a good eye to safety. The offshore wind industry is a relatively young industry, but it also means that a lot of new people are entering the offshore wind activities and need a relentless focus on safety. We see a great value of inclusiveness, of having diversification of thought, which gets you to gender diversification, but it could also be different aspects. The industry is pretty male dominated. If you look at the statistics, our own team here in Shell is slightly better. We have over a third of female employees within the wind teams. GWEC is a very interesting organization because they're the only wind organization that acts globally. Of course, there are regional offshore wind and wind associations. I think the role for GWEC is to really make wind global, but therefore also to think through its role. And so whether it's through safety standards that we talked about, whether it's through accreditation of technicians or people that work in the industry, I think GWEC can do very good work there that is not happening in the regional associations.
Driving down the levelized cost of energy is the challenge. Levelized cost of energy in non-technical terms is the cost at which the energy should be sold by any producer to break even. Ingeteam is an international technological group. We are present in 22 countries and we involved in the wind industry since 1995 when we supplied our first doubly fed system for a wind turbine. Innovation is the only way to help driving down the cost, achieving higher levels of quality and reducing the lead times. Together with that push towards lower levelized cost of energy, digitalization is bringing new standards and is bringing new levels of reliability, predictability, and risk management to the asset owners. For the wind industry, we offer our power converters, our generators, our SCADA systems, CMS, and we also include an offer of operation and maintenance. GWEC works at highest international political levels. Its market intelligence, task forces, and networking provides key insights for our company to help grow our business. Our mission is to promote the global transition to clean energy. We truly believe that a continuous effort in innovation is the only way to succeed.
The challenge really is speed. The wind sector has grown enormously over the last 20, 25 years, but it needs to grow a lot faster. And we're talking about large-scale kind of engineering projects and things like permitting and licensing, and it can take too long. Some of the very big offshore wind projects which are now going into construction in the UK, those were licensed kind of 8 or 10 years ago. If we're going to deploy on the scale we need, it kind of needs to go faster. But it really requires partnership between lots of different people. And that's one of the key things. I mean, I think wind has often been slowed down either by regulation that's not fit for purpose or by people objecting to projects. So it really takes a partnership between government, industry and the private sector and investors, but also communities.
Technology is being improved on an ongoing basis, so we can make better and more efficient use of our wind resources. This rapid growth and development is in part thanks to research and testing organizations such as the Fraunhofer Institute for Wind Energy Systems.
After having achieved to deliver the cheapest renewable energy down to around 2 cents per kilowatt hour at windy sites, we are now facing new challenges like land constraints, grid integration issue, or storage demands. Answers like offshore wind or hydrogen coupling are new topics we have to deal with. We are constantly pushing the boundaries of our engineering knowledge. We are working on the largest rotating machines mankind has ever built, with rotor diameters up to 220 meters, which means blade lengths more than 100 meters. The main theme of the Institute is focus on validation. This means we want to de-risk upcoming technologies in all key areas of wind energy. Our approach is twofold. On one hand, we have large test facilities like this test rig here for rotor blades, but also for drivetrains, pitch bearings, support structures and other components. And we cooperate closely with industry to create de-risking approaches using these facilities. In the second step, we also create digital solutions, digital twins, to create additional values out of our measurements. Wind energy is far away from being a commodity. The developments are very dynamic, for example in the rotor blades area, where we see tremendous growth in the length of the rotor blades. Jointly with the industry, we are pushing the limits from straightforward engineering to one of the most advanced technologies globally. We deal with controls, structural dynamics, or material science, and bring these topics from the highest scientific level of basic research down to applications in the field. We see the wind industry developing in a huge pace on a global level. We call this a global innovation chain. GWEC gives us international visibility and the support to be part of this global network beyond Germany and Europe.
new technologies are not just being developed to improve the capture of wind. We are also developing new ways to capture the power of wind in places that were previously unreachable, but which offer great wind potential.
The offshore wind industry is still largely regional because it relies on fixed bottom technologies that are piled directly into the seafloor. This means that with greater water depths, the costs and risks of installing these technologies grow exponentially. So recognizing that over 80% of the world's offshore wind resource is in water depths greater than 40 meters, Principal Power started working on a floating technology about 10 years ago. The technology is called the wind float, and it enables offshore wind turbines to be installed irrespective of water depth or seabed conditions. So Principal Power is a technology and services company with global operations. We have 100 megawatts of floating offshore wind projects that are under construction or advanced development in Portugal, France, and the United Kingdom. And we're developing a multi-gigawatt portfolio with our customers worldwide. The wind float is a semi-submersible technology derived from the oil and gas industry that has been adapted to allow offshore wind turbines to be installed in water depths from 40 to 1,000 meters. One of the unique features about the wind float technology is that it is very stable and it has a shallow draft. And this means that you're able to install the wind float at port, doing all the construction with onshore cranes, and then towing it offshore to its final location where it will operate for the project life. And we see that floating wind technology will contribute in a meaningful way to the overall blue economy, creating jobs and local impacts during development, construction, and operations. So for Principal Power, the value of being a member of GWEC is the access to the market intelligence that we get all around the world, as well as just the general access to policymakers.
Wind power is clearly continuing to grow as an industry. However, this growth is not happening fast enough to meet the IPCC's carbon reduction goals.
The world needs to speed up the deployment of renewable energy. And I think governments are increasingly going to have to look at things in a different way. We can't have wind farms being held up by endless legal challenges or bureaucratic red tape. We're going to need a kind of streamlined framework for being able to build at quite a high pace. I grew up here in Shoreham. Behind us, this used to be one of the biggest coal-powered plants in the UK. It was literally spewing out toxic chemicals and poisoning the people around here. That was demolished in the 1980s and was replaced by this gas power plant that you can see here. And then now we have the Rampion offshore wind farm, which is out over here. And that offshore wind farm is now enough to supply half of the power needs of the whole of Sussex. It's been a real success story, and I think people look out now and see these turbines and feel that they're living in a better world and a better environment. And I think that transformation is something that we're going to see, or we are seeing, and we're going to see all around the world.